Hello, Mr. Peterson here with some physical science concepts. Today we're going to be talking about elements and compounds, specifically what's a pure substance, metals, nonmetals, and metalloids, and if elements and compounds are pure substances. Well, let's dive right in. A pure substance is composed of only one type of particle. So in front of you I have three different pictures, some of them showing what a pure substance is, some of them showing what a pure substance is not. So if it's only composed of one particle, picture number one is a pure substance because it's a gray sphere over and over and over again. It's exactly the same size, shape, everything. Now picture number two has white spheres in it, so it is not a pure substance because it's composed of different things. Now number three looks a little bit different because it does have actually more than one part, but if we look at each individual part of the kind of Mickey Mouse, you'll notice they're all exactly the same. That makes that a pure substance because it's composed of the same thing over and over again. For instance, if this was water, this would be H2 because there's two white spheres. Oh, one gray. That would be a pure substance. All right, let's move on. Next, we're going to talk about an element. An element is a pure substance that cannot be separated by either chemical or physical means. So if I look at gold, which is an example of an element, I can see if I zoom in, at the molecular level, all of those particles are exactly the same. So they look the same regardless of where they're at in the universe or where they're at on the gold. Now, if I look at sand and I zoom in really, really close, I can see this is made of different particles. It's made of different parts, and I can actually pick each part out. So that is not an element because it's not composed of one thing. Now, all elements are found on the periodic table. And on the periodic table, there's different parts of elements. There are metals, which are located to the left of the zigzag line. There's metalloids, which are located on the zigzag line, so those are showcased as the light blue over here. And then there's nonmetals. Nonmetals are to the right of the zigzag line. Now, how I can tell the difference between these are the properties of them, such as nonmetals break very easily or are brittle. So I would show that by having this picture. They also do not contain other properties of a metal. Metals, for instance, are malleable, meaning that they can be bent or they can be changed in shape. They are also ductile, which means that they can be drawn into a wire. They are good conductors of electricity and thermal energy, and they have luster, or they are shiny. Now the metalloids, located on this area right here in the blue, those have properties of both metals and nonmetals. So they might be dull, but they might also be shiny. They might be brittle, but they could be also malleable. Or they could be kind of good conductors, but not that great. So the different properties depend on where they're at on the periodic table. Now, so let's review a little bit. If I have an element that is shiny, a good conductor, and malleable, what type of element is it? You're right, it's a metal. Good job, because metals are shiny, they're good conductors, and they're malleable. Now, if I have an element that is dull, a good conductor, and unmalleable, what type of element is it? You're right, totally right, a metalloid. Okay, a metalloid. Dull is a non-metal property, good conductor is a metal property. So since I have both, it's not a metal or a non-metal, it's a metalloid because it has properties of both. Last question. If I have an element that is dull, a bad conductor, and unductile, what type of element is it? You're right. It is a non-metal because it has properties of non-metals. All right, let's keep moving. All right, the next one we're going to talk about is a compound. Now, a compound also is a pure substance. It's composed of two or more elements that are chemically combined. What picture represents a compound? So if I look over here, is this composed of two or more elements? Nope, it is not. So it is not a compound. Is this composed of two or more elements? Possibly, but are they chemically bonded together? They are not. Now when things chemically bond together, it's called a reaction, which is what I have over here. I have two or more elements that have bonded together to create something different. So you can see these Mickey Mouse, or probably water, are a compound because they're composed of two or more elements and they're bonded to create a new substance. And that's the big thing. It's a new substance that's different. All right. Now, once again, compounds are a new substance. So let's look at a specific compound. Okay. I have some well-known compounds over here. I have hydrogen, oxygen, nitrogen. Now, if you notice, hydrogen doesn't hang out just hydrogen by itself. It actually bonds to create a compound of H2, or two hydrogens. We breathe in oxygen, O2, as two forms of oxygen, or two molecules of oxygen bonded together. Now what I wanted to look at is sodium right here. Now sodium is a metal. We're just going to watch this little video for a second, so go ahead. What? That's crazy! Holy buckets. So if we notice sodium, when we put it in water, what happens? It gives off fire, gives off heat, gives off energy, gives off smoke. Okay. Now, chlorine is a poisonous gas, meaning that when we breathe it in, we die. That's not a good thing. Now, sodium and chlorine, if I bond them together, I actually get a compound called salt or table salt. I put salt on lots of things. I don't burn up like in this video. Whoa, like in this video. I don't explode and things like that, but I also do not die because of the poisonous gas. So when sodium and chlorine bond together to create a compound, they make a new substance that is no longer deadly because it has different properties than the elements that make it up. All right, let's keep moving. All right, now what does a chemical and what does a physical mean? Well, a physical means that there's new substances not created, and a chemical means that a new substance is. Okay, so over here, if I freeze water, it's still water, it's just an ice cube. If I add a hydrogen to something to change hydrogen to hydrogen peroxide, that's totally different. Hydrogen peroxide and water are not the same thing. So I have some pictures. So glass breaking, is that physical or chemical? Good job. It's physical because it's breaking. It's still glass. It's just in smaller pieces. All right. Over here, ice cube melting. It's water turning to liquid water. So it's a physical change because it's still the same thing. Okay, over here, a nail rusting. Now I know it's still a nail, but is the metal on the nails the same thing? No, it's a new thing. It's changed, it's different, so that's a chemical change. Okay, over here, paper burning. Well, if I look at paper burning, when it burns, is it something created different? Yes, because ash is not the same as the paper. And the last one that I have over here, this is what's called electrolysis. Okay, and what that means is basically I have this tube full of water. Okay, and then I put some parts to it to run electricity across it. When I do, I actually separate the hydrogen and oxygen of the water. And when I look at this, you can see this balloon is twice the size of that because water is made of H2O. So I have twice as many hydrogens as I do oxygen. So as I run that electricity across it, I start to break that up. That's really all I have for over elements and compounds. But I want to remind you, go to the 7th grade physical science website for Pleasant Valley Junior High if you want to find some more answers on this. Do not hesitate to ask your teacher if you need some more help, and I hope this video was informative for you. Thank you very much.